Okay, a revision of last time what I taught, okay, and then we continue. Maybe some of you were absent last time, so you can understand that and then we carry on. A revision of last time's lesson. Last time I told you that the turning effect of force is called moment of force, or we call it torque, T-O-R-Q-U-E. What is the formula of torque? Torque formula is F into perpendicular distance. So in the diagram we show like this. How to calculate torque? Suppose here is a body, there will be a point about which the body will be pivoted, or about which the body will be hinged. The body will not be able to move freely, or the body will be clamped or pivoted or hinged. We have to give a force like this. Here is the force we are giving. This distance is D. Then torque or moment of force MOF is equal to the formula will be F into perpendicular distance. This is the sign of perpendicular, the perpendicular distance. One simple example is the force value is suppose 10 Newton and distance is 2 meter. So how much is the value of torque? 10 multiplied by 2. 10 to the 20. Unit will be also multiplied. Newton and meter multiplies. So the answer, the unit will become Newton meter. We say 20 Newton meter. That is the answer. Very simple. That is, moment of force depends on two factors, force and perpendicular distance. The SI unit of moment of force is Newton meter multiplied Newton meter. Whereas the CGS unit is dyne centimeter. We gave the definition of 1 Newton meter, 1 dyne centimeter. 1 Newton meter will make 10 to the power of 10 to the power of 7 dyne centimeter. So this is the recap of last times. Then I told you that moment of force is a vector quantity, it has direction. When a body turns, we are just recapitulating of last time's lesson. When a body turns in anti-clockwise direction, the sign of the moment of force, the sign of the torque will be positive. Anti-clockwise will have a positive sign, and clockwise moment or clockwise torque will have a negative sign. So this is all last time the main key points we have discussed, and one more important thing we discuss is that torque formula, we have force into perpendicular distance. If torque is constant, then force and perpendicular distance are inversely, that will come down as in divide like this. F and D are inversely proportional like this. If the distance is more, force will be less. If the distance is less, then the force is more. If we are having this distance longer, then the force value will be smaller. If the force is closer, then if the distance is closer, then the force will be larger. So this is the reason we have many results type question based on this fact, and I discussed last time why a handle is placed at the edge of a door. Suppose here is a door, we place the handle over here because we are going for the maximum distance. When the distance is maximum, then the force or the effort needed to produce turning effect in the door will become minimum. With the minimum effort or with the minimum force, we can produce turning effect in the door. We can open and close. So that will be the easiest way of producing a turning effect in a door. Spanners, wrenches, screwdrivers, they all are provided with long handle. Longer the handle, lesser the effort needed. We will be writing exactly like this. For a given torque, force is inversely proportional to the distance. When the distance is large, when the distance of the point of application of force from the pivoted point is large, then the value of force is less, or the value of effort becomes less. By doing so, by increasing the distance, we are reducing the amount of effort. If you write this much, you will be fine. We have jack. Jack is provided with a long handle, so that longer the handle, lesser the effort required to produce turning effect. With much less effort, we can lift the entire car. We can produce turning effect in the jack. That is the idea. If the handle is short, it will be difficult. You need to apply large force on it, and that force you may not be able to supply. So this is what we discussed last time. So now we will be continuing with the same topic and more details now. Next heading we can give is couple. COUPLE. Couple means pair. In relation to the physics or in relation to the chapter 4, we say a pair of equal and opposite forces whose line of action is not the same is called couple. Please write down a pair of equal and opposite forces. A pair of equal and opposite forces producing rotation in a body. Producing rotation in a body is called a couple. The line of action of such forces are not same. So I'll draw a diagram and show you what is a couple. So let us take a body like this, and we'll be giving one force here in the downward direction, here one force will give in the upward direction. You have to give equal force. One force is here, another force is here. Both the forces will be perpendicular. Forces values are equal, but they must act in the opposite direction at different points. The line of action of this force, line of action if we draw, line of action is dotted line like this. Here the dotted line. Do you think they have the same line of action? They do not have same line of action. So such forces are called a couple. What is the role of a couple? Couple will produce rotation in the body about its midpoint. The body will start turning about its midpoint, exactly midway. The body will start rotating or turning. Simple example, suppose we are having this pen and I want to turn it. Give a force like this and give a force this way, the opposite way, like this way. The body will turn about the midpoint over here. There are many such cases we have in the daily life or in our practical life. The example of couple is turning a tap. When we turn a tap, we use both the fingers. One finger will push, both the fingers will push in the opposite direction. One is like this, another one is like this. What happens then? The tap starts turning about the midpoint. There is a midpoint. We got a bike handle of a scooty or handle of a motorbike. Right at the middle there is a fulcrum about which the body moves, the handle moves, and we use both hands, and both the hands will move in the opposite direction. One hand we push this side and another hand this side we push, and then we produce rotation in the handle. So there also we are going for couple of the forces, means we are applying two forces. What is called, suppose if we are having a body like this, but if you give a force like this, F over here and F over here, like this, forces are equal and they are in opposite direction. Do you think these two forces will be called couple and will they cause rotation? Answer is no. Why? Because the line of action is same. The line of action of this and this is same. So they will not produce rotation. Their line of action has to be different. Then only they will produce rotation in the body. What are example of couple or turning effect of force in our daily lives? I said turning a tap, turning a key, turning the bike's handle or the scooty's handle, where we are giving the forces in both the directions, like this way, both the hands we are using there. So whichever body we want to turn, or whichever body turns about the midpoint, so there we must be going for this one, couple. We are applying two forces in the value will be equal, but they will be acting in the opposite direction. These two forces is called couple of forces, and we have a formula for couple of forces is like this. Right? Torque or moment of force, torque or moment of force, we write in short MOF. MOF is moment of force. It's the same thing. Torque or moment of force due to a couple equal to, formula will be writing as F into, here the total distance between the two forces will take as D. Here we write F into D. The formula does not change. F into the total distance between these two forces totally. We will take one of the force, remember it. We will take one of the force and multiply by the total distance over here. That is the formula of torque or the moment of force of a couple. One simple example, suppose F is 10 Newton. Here also it is 10 Newton. And the distance between two of them is 2 meter. The entire distance, total distance is 2 meter, like this. What is the value of the torque produced by these two forces? What is the value of total torque or the total moment of force? We'll take one of the force, that is 10, multiplied by the total distance. What is the total distance? 2. So 10 to the 20. The answer will come like this directly. 10 into 2, 10 to the 20. Unit will be Newton multiplied by meter. Newton meter. That is the answer. Though this question we can do part wise, but the answer comes the same. This entire thing is 2 meter, then half of this will be how much? 1 meter. This also will be 1 meter. So here we can write total moment of force will be, take part wise about the midpoint, like 10 into 1 we write, that is 10 into 1 plus again 10 into 1 we can write 10 plus 10, answer is 10, 20 Newton meter. That will be the answer. So if you take part wise, then you have to take that force multiplied by the distance, this force multiplied by this distance and add them, because they are producing rotation in the same direction. For same direction we are adding them. The answer is coming 20 Newton meter. If you want to learn the why it becomes like this exactly, though this thing will not be coming, but I just tell you, suppose this distance I take as x, this distance also I take as x, and F remains as it is. The moment of force due to couple will become as F into x, again F into x. F you can take common, it become x plus x, right? F, x plus x will become what? D. So you can write F into D. That is why formula becomes one of the forces and the distance between the two forces. That is called couple arm. Arm is the perpendicular distance between the two forces. That is called couple arm. From here till here the distance is called couple arm. So here we can write one of the forces, in what we can write here, one of the forces into couple arm. This is the formula of torque due to a couple. Torque due to a couple. Please note down this formula. This is an important formula. While they give a question problems in the question, suppose given, we can directly write 10 multiplied with, we'll use one of the force because we are taking the total distance from here to here. We are not taking the distance from the pivoted point. So we will be taking 10 multiplied with the total distance, that is 2. So 10 into 2, the answer is 20. Unit will multiply Newton meter multiplies Newton meter is the answer. Okay, one interesting question. Just think and answer. Can we turn a body? Can we turn a body without force? Without force, can a body be turned? Can a body be turned without having net force acting on it? Is it possible to turn a body without applying force on it? The answer is yes. This is very interesting. For any this type of question, the answer will be always, because if it is not possible, the question would not have arisen. Since there is a question, the question is asking you, that means the answer will be always yes. But you have to think about the examples or the cases where it is possible. Since possibility is there, that's why question is arising. If there is no possibility, question doesn't arise. This is possible. We can turn a body without having force on it. Here is the example. This is the example. Couple is the example. I'll tell you a thing. What is the value of net force acting on the body? 10 Newton is upward and 10 Newton has to be equal, no, in opposite direction. 10 is up, 10 is down. What is the total force? 10 minus 10. What is the answer coming? 0. Total force acting on the body becomes 0. Total force on the body is 0. Yet the body is telling the torque is not 0. Torque value is coming out here. F into d. We are having certain values coming out. So this is very much possible where the body is turning up, when the body is rotated under the action of a couple. This is quite interesting because the student will think, no, without using force, without having force, how can we turn the body? But we are not saying practically, I mean, you are applying the forces, but you are applying two forces equal in opposite direction. Net force becomes 0. Net means the total force becoming 0, but the torque is not becoming 0. So please note it down and write out with the asterisk or the asterisk point. Like this, right? Right. A body can be turned. Please write it down. This type of question may come in Icse exam. Okay. A body can be turned without force. Without force. Without force. Under the action of a couple, under the action of a couple. Full stop. You can elaborate your answer now. That when a body turns under the influence of a couple, under the influence of a couple, the net force on the body is 0. The net force on the body is 0. But the moment of force, but the MOF, moment of force, MOF full form is moment of force, MOMENT, moment. But the moment of force or the torque on it is not 0. I hope you understood this point. This was slightly interesting case. What are the examples of turning effect? Let us talk about only turning effect. Turning effect example is the door. Door we are opening, closing, so we are making use of turning effect. We are turning a tap using both the fingers. There we are going for a couple. Turning the handle of a two-wheeler, cycle or any kind of two-wheeler, the handle you are turning. So that is also the example of couple, because there we are using both the hands or both the fingers. We are applying the force on both the sides. Steering wheel of a car, steering wheel. Car, we got the steering wheel. The driver using both the hands and moving the wheel. So there also we are going for couple. Couple comes under turning effect only. If they give some examples of moment of force or the torque in our daily lives, you can think and answer and give the example. Turning a key of a lock. When you turn the key, so there also you are using both the fingers. You are opening a bottle cap. You are using both the fingers and opening like this. So there also is the example of couple or turning effect of force. So this much, these are the things you are supposed to know under the moment of force or the torque. Now we are doing the next topic. Definitely there are problems in this chapter. So when we do the problems, then you will get a better idea of this moment of force, how we find and how do we take sign and all. So that time I first I have finished the theory part, then we will do the problems. Next heading you can give equilibrium. What do you mean by equilibrium? Equilibrium is the word which means balance. Normally its general meaning is balance. But how do we define equilibrium? We say when the state of rest or the state of motion of a body, when the state of rest, or you can write it down, when the state of rest or motion of a body does not change, does not change, does not change under the influence of several forces acting on it, under the influence of several forces acting on it, several forces acting on it, then the body is said to be in equilibrium. Then the body is said to be in equilibrium. Then the body is said to be in equilibrium. Then after that you write down necessary conditions for equilibrium. Necessary conditions. Necessary conditions for equilibrium. There are two necessary conditions, number 1 and number 2. First one we write, when sum of all the forces or we don't add when, just add sum of all the forces acting on the body, sum of all the forces acting on the body, sum of all the forces acting on the body should be zero, should be zero, should be zero. Full stop, right on. This is the necessary condition for, this is the necessary condition for translational equilibrium, translational equilibrium. This is a necessary condition for translational equilibrium. Okay, you can write under bracket summation f0, summation f equal to 0. First you write it down, then I'll explain. Summation f equal to 0. This is the sign of summation, sigma, summation. Number 2 you write down when the total moment of forces, when the total moment of forces about the pivoted point is zero, should be 0. Don't add when, just add the cancel when, just add the total moment of forces about the pivoted point should be 0. Then write this is the necessary condition for, this is the necessary condition for rotational equilibrium, rotational equilibrium. Second one, rotational equilibrium, rotational equilibrium. Under bracket you write summation of torque must be 0. Sum of all the torques must be 0. Okay, you can understand what is the meaning of translational equilibrium. Translational motion is straight line motion. When the net force acting on the body is 0, the body will not have translational motion. The body will be in equilibrium. Or if the body is already moving, it will continue to move with the same velocity in the same direction because the net force acting on it is 0. That is the first case. If a body is pivoted about a point, pivoted means like clamped, or we are having a hinged, the body is hinged somewhere, then there you have to go for this condition. Their total moment of force or the total amount of torque acting on the body about the pivoted point must be 0. That is the necessary condition for rotational equilibrium. So your question may come in bits and parts. Question may come, a body is unpivoted. A body is unpivoted. What is the necessary condition for its equilibrium? There you will say this one. Sum of all the forces acting on the body must be 0. That one you will say. Or if question comes, a body is moving in a straight line path. Question will say a body is moving in a straight line path. How can it be in equilibrium? Then you will say that the sum of all the forces acting on the body must be 0. Then only the body will be in this equilibrium, translational equilibrium. Means motion or state of rest must not be affected. It will remain in the same state. Though various forces are acting on it, yet its state of rest or state of motion is maintained. Then we say that the body is in equilibrium. Rotational equilibrium time, the body will be pivoted, the body will be hinged somewhere. That time we have to see the sum of all the moment of force, the total torque acting about the point of rotation or about the pivoted point must be 0. I am using the word pivoted, P-I-V-O-T-E-D. Pivoted means that the point where the body is about to turn. I mean that point we can call hinge, we can call it knife edge, we can call it a support, we can call it about that the body will be turning about that point. That is called pivoted point. If question will give the necessary condition for translation equilibrium, we will mention this one. Give the necessary condition for rotational equilibrium, we will give this one. Or just give the conditions for necessary condition for equilibrium, you have to give both. Then the question will be carrying 2 marks. Otherwise, only one part, so 1 mark only will come. I hope you understood this one. Now there are 2 types of equilibrium. Types of equilibrium, right now. Types of equilibrium. Types of equilibrium. Number 1, static equilibrium. And number 2, little gap I'm leaving, so dynamic equilibrium. Dynamic equilibrium. Dynamic equilibrium. Static means rest and dynamic means motion. Here, what is static equilibrium? We say when the state of rest of a body does not change. When the state of rest of a body does not change under the influence of several forces acting on it, then the body is said to be in static equilibrium. The body will remain at rest. Though various forces may be acting on it, yet the body will remain in the state of rest. Such an equilibrium is called static equilibrium. What are the examples of static equilibrium in our daily lives? We say a stone on the ground remains at rest, though sometimes wind blows, sometimes we apply force on it also, yet the big piece of stone doesn't move on it, remains still at rest. A bridge, or common balance. These are all the examples of static equilibrium. Building remains at rest, though cyclone sometimes comes, heavy cyclone comes, sometimes rainfall takes place, sometimes hailstorm will be there. Bridges around, so many cars around flying over it. So their state of rest does not change. They do not collapse, they remain at rest. So these are the examples of static equilibrium. Common balance. You know that common balance with which we measure the weight of something. One side you have a pan, another side you will have another pan, and you keep one side the materials which you want to weigh, and other side you will be weighing it with some weights, iron weights you keep on the other side. And when the beam is horizontal, like this, then we say this will be, both the pans will be in equilibrium there, and you measure the weight of vegetables and also. That is a common balance or beam balance we can write, or a beam balance. Except the spring balance. Spring balance is different. Spring balance doesn't have turning effect there. There is a spring, the spring gets stretched. That the working of spring balance is different. One year we had asked this question: a beam balance in horizontal position. A beam balance in horizontal position like this. A beam balance in horizontal position is in dash equilibrium. You have to fill in the blank. Dash equilibrium. What you should fill in the blank? Static. You should write static there. The word static you have to fill in the blank. That question came some year back in Icse. Now coming to this dynamic equilibrium. What is the dynamic equilibrium? We say when the state of motion, dynamic means motion, when the state of motion of a body does not change under the influence of several forces acting on it, then the body is said to be in dynamic equilibrium. When the state of rest does not change under the influence of several forces acting on it, we say it is in static equilibrium. But when the state of motion of a body does not change under the influence of several forces acting, then the body is said to be in dynamic equilibrium. What are the examples of dynamic? These are the examples I have given examples. Now let us take the examples of dynamic equilibrium. We say raindrops falling near the ground, electrons revolving around the nucleus, around the nucleus, planets revolving around the sun. These are the example of dynamic equilibrium. Raindrops, when they fall near the ground levels, they continuously fall down like this. Though the several forces are acting on it, what are the forces? The weight of the drops is acting downward, and the friction or the upthrust is acting in the upward direction. Upthrust is given by the air, that is acting in the upward direction. Yet the motion of the drop continues. Drop still falls down. Then what kind of equilibrium the raindrops will be in? The raindrops will be in dynamic equilibrium. You know, electrons continuously revolves around the nucleus of an atom. Though the different kind of forces are acting on there, yet the motion of electron remains undisturbed, unaffected. It continues revolving throughout. What kind of equilibrium the electron is in? Dynamic equilibrium. Planets continuously revolving around the sun without getting tired. What kind of equilibrium the planets are? We say in dynamic equilibrium. So at least one or two examples you should know of each case. Or sometimes they may give an example and you have to write down which type of equilibrium the body is in. Is it in static equilibrium or dynamic equilibrium? Hope you understood this topic. Equilibrium. Now the next topic is principle of moments. Principle of moments. Okay, write down the statement of principle of moments. It states that the total clockwise moment moment of the forces about a point is equal to the total anti-clockwise moment is equal to the total anti-clockwise moment it states that the total clockwise moment about a point is equal to the total anti-clockwise moment about the same point to keep it in equilibrium So that is the statement of principle of moments. Therefore we can write a total or you can write on top at equilibrium total clockwise moment equal to total anti-clockwise moment. We write out this information. Total clockwise moment is equal to the total anti-clockwise moment. This principle is called principle of moments. Moments of both the sides you are making equal, and total moment will become zero. Then the body will remain in equilibrium. What kind of equilibrium? This will be rotational equilibrium. The body will not be turning. Because the body is pivoted, the body cannot have a translational motion. The body at the most can turn. But in this situation, the turning effect will be zero. There will be no turning effect. Total clockwise moment, and if anti-clockwise moments are equal, then the body will remain in equilibrium. Total clockwise moments will act is equal to total anti-clockwise moment. Let us see by an example. Like they may give a diagram like this. Just see, have a look. Let us take a meter rule we are taking, starting from 0 and ending at 100. It is pivoted at the midpoint here. There is here is the pivoted point O. We are balancing it by giving a force over here like this. There is a force that is W1 and there is a force here W2. Here the distance I take as L1. Here the distance will be L2. This distance is L2. Then this meter rule is in horizontal position. Question says the diagram shows a meter rule. Question will come like this. The diagram shows a meter rule. What is it in 50? 50 is it here? 50 centimeter. The diagram shows a meter rule in horizontal position. Question is saying like that, in horizontal positions. Name the law or the principle on which it is based. First question. Name the law or the principle on which the diagram is based. The answer will be that there is no law, but there is a principle. What is the name of the principle? Principle of moments. You write that. It is based on the principle of moments. That answer you will give. Okay. Write down the relationship between W1 and W2. Write down the relationship. Then you will be writing like this. Clockwise moment. This side will be clockwise moment because this will produce turning effect like this. Here is the pivoted point. So this will be causing it to turn like this clockwise. This will give anti-clockwise moment. You can write anyone first, anyone later on. So anti-clockwise like this. W1 into this moment is L1. Distance is L1. And out here like W2 into 2. This equation will be right. Third question may come like this. Which of the two weights as shown in the diagram is larger? W1 and W2, out of these two, which one is larger? And give a reason for it. Can you identify which one is bigger? W1 will be bigger or W2 will be bigger? I'll tell you the answer. You have to, for that question, you have to look for the distance. As I told you in the beginning, that when the distance is large, force will be less. If the distance is less, then the force will be more. The distance of which force is less? W2 is less from the pivoted point. If this distance is less and this distance is more. When the distance is less, the force will be bigger. Here the distance is large, the force will be smaller. Which one is bigger? W1 or W2? Which of them is bigger? We say W2, because W2 is closer to the pivoted point, closer. When the distance from the pivoted point to the point of action of force, to the line of action of force is smaller, then the force will become bigger. We will be writing as W2 will be bigger than W1 since, reason we give since L2 is smaller than L1. This is a sign of smaller. When the distance is less, force is more. When the distance is more, force is less. So that is the idea behind this question. This question, solid question, may come for 3 marks in your batch next year. So these are the probable questions, because this type of questions, when last time I had gone to Kolkata, I had an examiner there. So we all discussed this kind of possibilities there. So there is a high chance of this question coming in your ICC exams. So please be mentally prepared and learn it well. Try to understand also the concepts behind. Hope you understood till this part. Name the law or the principle on which it is based. It's a principle of moment. Question may carry 3 marks. First question, name the law, which is a principle of moments. Second question, write down the equation or write down the relationship between W1 and W2. You write down this relation. Third part of question says, which of the two force, W1, W2 is bigger? And give reasons for it. So reason you are given like this. Or you can write even in the words, since W1 is closer to the fulcrum, so it is larger. Because larger the distance, shorter the distance, larger the force. Larger the distance, smaller is the force. So that is the idea behind it. So today we are doing till this portion, till the principle of moments. Next day we will continue and will be doing the theory parts. At least we will be able to finish by the next class of this chapter. Then we have to do the problems.